Hi everyone, so my name is Tina and today I'll be talking to you all about Babylon.js, which is a JavaScript API for building 3D games with the help of HTML5, Web Audio, and WebGL. So before I dive into my demo and show you sort of how to build a 3D object, I'm going to talk to you a little bit about 3D basics and about the API that Babylon is based on, which is WebGL. So what exactly is WebGL? It's also a JavaScript API for rendering 3D graphics in your web browser and without the help of any plugins. You can do anything from like doing 3D mapping to animated animations, virtual tours, etc., etc. But I like to think of it as like the more complicated, like older sibling to Babylon. And so how does WebGL do this? Let's take a look at this rendering of a monkey head from start to finish. So WebGL is just a rasterization engine, which is just fancy words for meaning it takes like vectors and turns them into images and pixels. It draws points, lines, and triangles based on code that you supply. And this code you supply to WebGL in the form of pairs of functions called a vertex shader and a fragment shader, which you can see on the left and right. So they are written in a very strictly typed C++ language called GLSL, which stands for GL shader language. And as you can see, to rasterize graphics, you need a lot of math, a lot of geometry, a lot of complicated things that I really don't even know what that like says over there. So this, of course, all comes with a really steep learning curve, and that is where Babylon.js comes in. Babylon is an open source WebGL-based 3D engine that abstracts away all of the complexities that I just mentioned, so you don't have to deal with, well, you still have to deal with some math, but like a lot less than like if you were writing it from scratch. So while doing like a 3D object in WebGL would be a ton of code, it would be a lot less in Babylon. So even novice JavaScript developers like us can build 3D games and animations. So since it's game-focused, Babylon has extra features that a regular 3D engine wouldn't, like a physics engine, collision detection, and native support for the Oculus Rift and other VR devices, making it really easy to sort of do things for VR devices. And here are some examples of some cool projects that you can see if you go on like Babylon's website, and even this fun spaceship. But you know, my demo won't be this, but I'll be showing you how to build a 3D object. So let me start with the setup. So setup is as easy as going to their website and downloading the latest version. Minified is for production and unminified is for debugging purposes only. Then all you have to do is import it into your HTML document with a script tag, and that's literally it. Now you can start coding and you have all the features of Babylon at your disposal. So here's the start of our HTML code with our imported Babylon script. If you notice, I have a hand.js script also, but I'll talk about that in a later slide. Before we begin coding, we'll have to add some styles in the head to make sure that Babylon renders the scene in full screen mode. And also, don't forget our canvas, which is the element that allows our browser access to the GPU to create the 3D elements. So the first thing you have to do to display anything is create an engine. This is pretty much what tells WebGL to create 3D objects. And you'll also have to check if your browser supports WebGL by adding this if statement. You could also go to getwebgl.org because not all browsers, especially the older versions, support it. Once you've created your engine class, you'll be able to create a scene where you can add all of the entities to work together to build your 3D object. So you can think of it like a stage. You have lights, cameras, and in our case, meshes and materials also. So now that we've created our scene, we're going to initialize a new camera. And Babylon has several cameras, but to keep it simple, I'm going to use this arc rotate camera, which rotates around a given pivot. Your first parameter is going to be the name of the name. The second is the alpha, which is the rotation around the y-axis. The next is beta, which is the rotation around the x-axis. Next is the radius of the camera. Next is the 3D position of the camera. And lastly is the scene. So there is still lots of math in here. So you have a camera, you have a scene, but you need light to see for an image to look sort of 3D. So Babylon has 4 types of lights, which are point, directional, spot, and in our case, hemispheric, which gives us the most realistic ambient environment lighting. It's defined by direction to the sky and three colors, 1 for pixels facing upwards, 1 for pixels facing downwards, and 1 for specular, which are like pretty much how the light shines on the surface of the object. We also get basic elements such as a box, sphere, plane, cylinder, torus, knot, and more. We're going to be creating a torus knot that has 8 parameters like name, radius, tube, radial segments, tubular segments, P, Q, and also scene. So now we have all of this, but we also need a material. Your object needs to be wrapped in something, so it's not just a boring object. So we're going to create a material and give it a name and apply this material to our created knot. In addition, every material also needs a color, so those are just RGB values divided by 255. But if we were to test our HTML file at this point, you would see nothing, and that's because we don't have a render loop yet. You need to register a render loop so that Babylon tells the scene to render all of the entities that it has, and that is composed of 4 parts: engine begin frame, which starts a new frame; scene.render, which asks the scene for a rendering object; engine.end frame, which passes the object back to the canvas; and queue new frame, which starts a new frame. And you're going to do this, well, not you, but like Babylon will do this 60 times per second for 60 FPS. So now if we were to test our HTML file, we would see a 3D object that looks something like on the left you see there. We're going to add this simple animation function so that it just spins around, and you're good to go. And I would like to show you exactly what our finished animation would look like in this case. So as you can see, this is the torus knot. The material is red, that's the color we picked, and this is just the standard material, and this is the hemispheric lighting. As you can see, it's sort of like shining on our knots. And oh, this is where hand.js comes in. If you click, you can rotate your knot and sort of spin it around and just keep spinning it, and that is where hand.js comes in. So this was just a really quick demo of how to build a simple 3D object with Babylon with an animation. And if you were to look at our code, this is our entire code. There's a couple of lines at the top, but that's just the beginning of the HTML. And as you can see, doing something like this in Babylon took about 50 lines of code, so it wasn't too bad. But if you were to do this equivalent in WebGL, it would be probably 500, 600, 700. So it's much, much more complicated. And so Babylon has really simplified and abstracted away the complexities of WebGL to allow, like, even me, who is terrible at geometry, I really hate geometry, to do 3D work like this. And yeah, so that is the magic of Babylon, and I hope you enjoyed my presentation. Thank you.